What is meant by ion exchange resin? Ion exchange resins are cross-linked, long-chain organic polymers which are microporous in nature, carrying exchangeable ions. These are of two types. Cation exchange resin carries acidic functional groups capable of exchanging their H plus ions. Anion exchange resin carries basic functional groups capable of exchanging their OH minus ions. Let us look into the process. This process requires two towers or columns. The first is cation exchange column, which is packed with the cation exchange resins capable of exchanging H plus ions. The anion exchange column is packed with anion exchange resin capable of exchanging OH minus ions. What is meant by raw water? It is nothing but all the water sources collected in a reservoir. This water will contain all types of minerals in it. For this example, let us consider that raw water contains calcium sulfate and NaCl in it. When this raw water is passed through the cation exchange resin, the H plus ions present in the cation exchange resin get exchanged with the calcium and sodium present in the water. Now the water coming out of this column is free from cations. When this water is passed through the anion exchange column, the OH minus ions present in the anion exchange resin get exchanged with the sulfate and chloride ions present in the water. The water coming out of this column is free from both cations and anions. This water is called as demineralized water as the minerals present in the waters are removed. This is also called as deionized water as the cations and the anions present in the water is removed. What will happen when the H plus ions and the OH minus ions get exchanged with the cations and the anions present in the water? We call such resins to be exhausted. That is, it is not capable of exchanging ions further. At this stage, we can regenerate the resins. The cation exchange resin can be regenerated by passing dilute HCl. When dilute HCl is passed through the cation exchange resin, the H plus ions present in dilute HCl get exchanged with the cations already present in the resin. When dilute NaOH is passed through the anion exchange resin, the OH minus ions present in dilute NaOH get exchanged with the anions present in the resin. Now the resins are ready for use again. Let us look into the reactions. In the cation exchange process, the H plus ions present in the resin get exchanged with the cations present in the water and releases H plus ions. In the anion exchange process, the OH minus ions present in the resin get exchanged with the anions present in the water and releases OH minus ions. The H plus ions released in the cation exchange column and the OH minus ions released in the anion exchange column combines to form water. When the resins are exhausted, we can regenerate the resins. The H plus ions present in dilute HCl get exchanged with the already present cations in the resin to give back the cation exchange resin. Similarly, the OH minus ions present in dilute NaOH get exchanged with the already present anions in the resin to give back the anion exchange resin. Now the resins are ready for reuse again. This process has many advantages. We can get water with hardness less than 2 ppm. Both acidic and alkaline water can be used in this process. Both the cations and anions can be removed in this process. But we do have some limitations in this process. The process is expensive as the resins and the installation costs are high. If turbidity is present in the water, the efficiency of the process is reduced. So, the turbidity has to be removed before going for this process. This method is also not suitable if heavy metals are present, as these heavy metals permanently sit over the ion exchange resin, and these resins cannot be regenerated again.